Well, hi, good morning. Thank you for joining me in my shop here on July 16th for me to do the alignment on this radio. Now, I might only get through the very first step, which would be doing the IFs, but the IF alignment. But hopefully, I get the whole thing done today. But first, what about these continuing mysteries in this radio? Mysteries in the radio. What is this? Now, maybe someone has provided an answer, maybe you, in the comments on previous videos on this radio. You may say, oh, you know what that is? That's a, my wild guess, it's just a wild guess. Some kind of resistor with a heat sink here. And this heat sink is screwed tight to the chassis, so this is grounded. It has one wire coming to it, and this high temperature insulator here. So my guess, it's a resistor. I've tried to spot it on the schematic, no luck. Meanwhile, we got this square block of ceramic here, a ceramic square block. Again, ceramic, it can mean something hot here. Again, I don't know what this is. There's no adjustment for it. It's just a screw coming down from the top to hold it in place. It's screwed into the chassis. Don't know what those things are. Not too many radios that come in front of me with parts I can't identify, but there's two. Okay, so what I've also done, you can see this clip lead that I have here. I've clipped it onto this terminal, which is the input side of the volume control ahead of the capacitor. You can kind of see the orange capacitor there. That's going to pick up the DC that's being generated by the detector, and it'll be on the end of this wire. I can put this on my voltmeter and watch the DC level go up and down. And what it reflects is the strength of the signal coming out of the IF. The strength of the signal that's being detected or rectified by the detector circuit. So the higher the voltage, and it's actually going negative. The more negative the voltage, the stronger the signal that's coming through the radio, and that's how you can make judgments. Now, often it's not recommended to do this in the alignment instructions. What the alignment instructions for these old radios often say is just monitor the volume at the speaker. I believe the reason they do that is because they know that most shops back in the day did not have meters with very high input impedances. And those low input impedance meters draw current from the circuit. You can't afford to draw any current from this circuit, any substantial current anyway. Enough to even operate just an old indicating meter. It's too much. And they don't know what quality of meter technicians have that are working on these radios back in the day. But you can hook up a low impedance meter across a speaker. There's no problem. There's lots of power available there to drive a meter. So that's where you could watch without interfering with the radio's operation. But I have meters that don't draw much current. Oh. Whoa! How about that? Like this meter. This guy draws, I think it's 10 megohms input, so it doesn't draw enough current to disturb the radio. So I can use that meter there, and that's what I'm going to do. So I brought this clip lead out because this is what I want to do with the radio. I want to tip it down. I think all the alignment is done from above. None of it is done underneath. So there we are. So first things I'm going to do are these two transformers. And once again, you can see very strong evidence that this tube is not original. That this tube and the socket that goes with it have been installed to allow this tube. The original tube was this tall. And you can see they've had to extend this down to here. Okay, that's just a bit of a story. Just a bit of a story. Very good. Okay, I'll get everything set up, warmed up, and we'll start on the IF. Okay, I'm off to a bad start here. Listen to this. Where's that coming from? So just having this wire here is enough to generate a bit of a hum. You can still hear it. Hooking it up to my voltmeter. Surprising to me, you introduces that hump. Now, is that throwing everything off? Okay, another little bit of a surprising thing. Just checking this before I turn on the camera. I'm going to tune the radio. This is the ABC voltage here. That's a negative voltage. It's not going anywhere at all. Ooh, it still does that, does it? Don't go past here. Well, I don't know what to make of that. I don't know what to make of that. Oh. And the other band, this is broadcast, this is shortwave. What's happened here? Let's give it a little bit of a signal to chew on. It's just nothing happening. I've got this connected to the wrong spot. This must be the case. I've done this wrong. Not sure how I can do it wrong, but I guess I found a way. What's the problem with this? Now I've turned the set off in case you didn't notice. How can this be wrong? So I'm pretty sure I proved this is a grounded terminal, and so this would be the input side. It's connected here. Where am I going wrong? Yeah, you don't know. Didn't I do this before? Haven't I done this before successfully? I don't understand what has happened. Yeah, I don't know. I don't know what to think of that. I gotta stop and wait for some ideas to come here. Okay, I got a guess. I'm going to guess it has to do with the location of the ground to the meter, which I'd simply put on the chassis at a convenient point back here somewhere. So it's connected back here. The volume control is over here. Perhaps there is a current in this chassis, and I'm picking it up, so to speak. Something, it's a terrible way of showing it, but something like that. I need to put the ground of the meter very close to the volume control in a more ideal location. Of course, part of the volume control is grounded right here. So I can clip the ground here and then try again with the voltmeter on this terminal and see if the hum reappears. So I don't know why I'm showing you that. I don't know. Let's turn the radio back on. We'll try this. So we'll connect the ground first of all. Right in here. Remember, this terminal is grounded right through the volume control. And then the other here, I'll have to get on the other side of this capacitor where the DC should be. Still humming the very same. Well, I can't say I've ever run into this. A hum coming back out of my... Gee, could it be? Could it be that what we're hearing is a voltage drop across these bulbs? Let me take them out of the circuit. No, that would not be it. That would not be it. Well, this I'll never do. I don't think we can do this. The hum is coming out of the speaker. Is the hum being generated in the audio circuits, or is it actually being generated back in the radio circuits? I'm not sure. Sounds like the audio circuits. It's most likely just the audio circuits. You could just turn the volume down and carry on and ignore it. But we saw the fixed voltage on the meter not changing. Oh my gosh, I haven't... See, it's a good thing that the roads I drive on don't have ditches, because I'd be in them immediately. So, the actual fact is, the street I live on has ditches. Big ditch in front of my house. I should go jump in it. I don't know. I gotta think this some more. More thinking. More coffee. Okay, the story has gotten complicated here. So what I've been doing is I've been looking for another place to attach my voltmeter, and I've simply traced the wire back. Oh my god, that radio switched on. Oh my god, stuck my fingers into it. Oh, 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 oh. Bad finger, bad finger. Oh my gosh. You know why that happened? I like to assess these things right away. I can't see the light. I can't see the light. I can't see the light, so I don't know what's on. Volume's down, no sound coming out of the speaker. So, and I can't see any of the tubes. So from this point of view, it's easy for me to forget. Bad finger. Bad Finger. Hey, wasn't there a band called Bad Finger? Bad Finger. Probably the guitars came up with that name. Okay, back to what I was saying. Strange things are happening here. So I'm following back from the schematic here. Currently I'm attached to this point here. You have a volume control, capacitor, and then this becomes, and then another capacitor going to the chassis. I gotta point with something a little bit better, I think. I don't know, what is this? Well, I can't find this capacitor. This wire that comes across, or this connection that comes over here, should connect to a resistor going in, two resistors. It does not. It connects to a terminal that connects to a resistor of some value, one resistor, and then a wire that runs over here. What? Furthermore, as I noticed earlier, previously, this IF has been removed. This guy's been removed and stuck back in again, and I can tell because all the wires have been cut and then reconnected, and it's done correctly. The right wires are connected together again, and then the guy used this black material to paint on some. It's like painting on electrical tape, kind of like that. So where is that resistor? So I looked on here, and I see. I looked on here. I looked down here. Resistor 21 and resistor 20. Well, why can I not find these? Well, maybe I'm finding one of them. There's a resistor right there. Okay, I can stick my finger in there now with pleasure. So 2021. So we look. So here we are. So 21 resistor, 490 ohms. Okay, that's maybe what that is. And yellow one, number 20 resistor, 51,000 ohms. Mounted in 19. Oh, what's 19? Surprise, second IF transformer. So this wire I'm seeing is on its way to the second IF transformer to encounter that resistor. This is the first IF transformer. This is the number 1. Am I kooky on that? I'm not kooky on that, am I? What do they actually say? This points to number 7. Number 7. Compensator. That's not even an IF. No, this doesn't even show the IF cans. They're not on here. Put like this. And the can is here. Oh, yes, they do. They show them like this. Show them as circles. 13. 13 is first. "13 is the first? This is the first?" No. Really? That's the first one? This schematic can't be wrong. Or this diagram can't be wrong, can it? Can't be wrong. First IF transformer. Well, that would make this one the second one, number 19. 19, yes, we saw before. Second IF transformer. Wow, I ever turned around in this radio. Because I would have bet, no, I did bet this would be the second one. And why am I suggesting that? Because the tuning is kind of happening down this way, and the sensitive RF tubes are down here. Usually, and the antenna connection's here, running into the switch. So we can't really trace that around. Okay, well that's the situation then. So I'm seeing a wire. Let me trace it with a stick. So I'm seeing this wire in here. There's the resistor, and then there's a wire. You can't see it very easily. It's this wire here. Oh, it's going right into this. This is number 2. Coming out of number 2. Yes, Jim, of course. Get it straight. I'm thinking the wrong way. It's not going in, it's coming out. The signal's coming out of the second IF and heading to the volume control, of course. And this is number 19. Am I right? I am. See, this is where my head comes off. This is labeled 13. No, 19. Yeah, head's back on. Head's my head's not screwed on very tight today. Okay, I'm all turned around, but everything's good because they've turned around again and everything's back. Okay, not making a lot of sense to you, I'm sure, but okay. So what's the problem? The resistor is tucked up inside here. Is that why this was removed? This was removed to go after the resistor? And did he boop it up somehow? Oh my gosh, I certainly don't want to take this out. So the hum is only there when I hook up something here. It's unexpected to me. It could just be, me. It could just be I got unreasonable expectations. So another possibility here is to do what I try to avoid all the time, which is to monitor the volume in the speaker. You could monitor a much larger AC signal coming out of the output here. I've never done it, but that's another way in which instructions often say, hook up your high voltage voltmeter. You're going to set it to AC and ignore the DC component in here, and measure the output, the AC output on the output tube itself, rather than the much lower voltage at the speaker. Then you can probably get away with not listening to the speaker so much. Well, as a matter of experiment, why don't I try this scheme here? Those wires, they go all the way up to the speaker, but nothing is exposed here to get at, except the voice coil is easily. Oh no, that's not the voice coil there. Nothing is easy to get at on that speaker. Okay, enough of that idea. We could, instead of going out here somewhere, pick it off. We really just pick it right off the plate connection of the output tube, which was pin 3, wasn't it? And the output tube up here. No, it can't be 3. 3's got nothing hooked up to it. Okay, I got a plan. I'm going to try to monitor the voltage on the output tube plate, the AC signal voltage, and use that as a guide. I'll use a modulated signal coming into the radio so we can hear a tone, or see a tone on the meter, I guess is the way to put it. Okay, I think I got a plan here, I think. I've run into another inexplicable situation, at least I can't explain it at all. So the output tube is a 6F6. 6F6. We look in the manual for 6F6. Here it is. 6F6 G and GT. It's a glass tube, the one I have. Look at the pin arrangement. So we have pin 1, which is not connected in a glass tube, but in a metal tube this might be connected. Pin 1. Pin 2 is one end of the heater. In this radio, one end of the heaters go to the chassis. In this radio, these two pins are soldered together with a wire. The next pin is pin 3. That's the plate pin. You can see it there. P, and a wire going to the plate. Okay, pin 3, pin 3, pin 3. If we look here, and I am double checking right now, this is definitely the tube in question. My pointer stick. Here we go. So here's pin 1. Pin 2, they're tied together, and they're going to a grounded terminal right here. Now, what's going on pin 3? It's hiding from view. There it is. Can you see? There's nothing attached to it. There's nothing attached to pin 3. I ran into this before, earlier. And I don't know what I did. I don't know what I did. I was doing voltage tests. I just moved on. And the next 3 seem to be the correct ones. The plate, screen, and grid in that order. I don't know what. Something's going on. Could be in my head. The way things are going today, it probably is in my head. So another alternative, heck with all that. We'll actually try to monitor the volume on the speaker, the amount of energy getting to the speaker. Here's a speaker. Right, so I'm looking at the wiring situation in here. I see no grounds attached anywhere to it. That's important because I'm going to put a voltmeter on here with a grounded lead. So that looks like a little hum coil there. We're going to try to get right on the voice coil. If you look at the speaker again more closely, because I didn't look at it close enough last time, you see the transformer, you see the heavy wires coming out. So I'm thinking, oh, heavy wires coming out, they're going into the field coil. But actually the field coil is on these wires here, which are coming around, and attaching and just going straight in the radio. So the field coil is quite isolated from the rest of the speaker in a sense. So what are these? So you look more closely, you can see from here a light wire. It's hidden around the back here. There it is, that light colored wire. And you can see its brother on this side. Well, that's got to be the voice coil leads, light wires. So if I connect here and here, should be reading the same voltage that's driving the voice coil, driving the speaker. Then I can just watch that voltage go up and down. Unfortunately, we'll have to listen to the speaker while we're doing it. And I should be able to attach a ground to it without any concern. Famous last words. So we're gonna poke around with this idea now. So the voltmeter set to AC. Way over here. Voltmeter set to AC and 50 volts to start off with. I have to switch this over to AC. There we are. Now, I don't want to put the ground on until this thing's operating and we're ready to do something. Power on, power on. Jeepers, this should have been just a straightforward shop session, but if you remember at the start, I think I mumbled something about if we can even get through the IF, because I know what happens here, at least to me. The path looks clear until you take one step on it, and suddenly the path is pretty crowded. Pretty difficult to follow because of weirdness. Again, all the weirdness could be in my head. Okay, this guy should be warmed up. Total volume. What's happened now? I haven't done anything. I didn't make it. There we go. Okay. What's happened here? So we're only running this guy with 85 volts. What's happened? Something has happened? Something in my coffee this morning? Something did. What's going on? So I'm touching the antenna here, expecting a to come out. Well, let's raise the supply voltage. 118 volts now. I can't imagine that made any difference. What's happened to this radio? This is not good. really, really going backwards here today. Let me touch another tube here. Okay, so that's the detector tube. And how about I touch this? That's, I think, was the oscillator capacitor in here. It's all there. It's all there. They didn't do anything to the radio. Apparently, I've done something to the radio. I'm totally floored. Let's give it a better antenna with my finger. Maybe it's just my finger's just not up to the job. There's a little bit there. Okay, it's working. Oh my gosh. This is a pretty weird day in Jim's shop. We'll leave that on so we can hear some sound while I attach this. The first ground lead from the voltmeter going on to that speaker. A little bit of a tap deal here. Nothing happens. Good. So I'm going to apply a ground here. Don't touch the frame. Okay, and then the actual voltmeter lead. What do we see on the voltmeter? Nothing. Really downhill day. Nothing there at all. Okay, I gotta crank up the volume. Nothing whatsoever. What is going on here today? Did this not make a connection? Am I thinking of what is wrong? No, it can't be wrong. It's not moving at all. Oh my gosh. I mean, it looks stymied at every turn this morning. Everything I do is just... Really, it's just... I'm living in the ditch here. Oh my gosh. How can that not be? How can you not see something on here? This is a 1.5 volt scale. So a tiny voltage is going to move this pointer up. They didn't seem to do a thing to it. The connection didn't take hold. Yeah, using a bad clip loop. Bad clip loop. Bad boy. I'm just getting another clip lead here. Nothing. It's a bad day in Jim's shop today. This is the simplest stuff. And none of it's working out. Wow, clearly I gotta stop and drink more coffee because Is this what's going on in the shop here? Okay, I think I found my mistake here. So this has got a bit of a complicated arrangement here with these two tubes, more complicated than most radios. Most radios combine these two functions here. So this tube is being used as a detector. Detector AVC generator. And this is the first audio. And you know what I had in my head just went out. I just blew my idea out. So really, the detecting the AVC voltage is on this line. It has nothing to do with all this. So I get away from that and get over here. I'm going to find this capacitor, 110 picofarads, on the plate circuit of this tube. So the plate circuit of this tube, look for a wire going to a resistor. Look for this resistor. Look for, actually, just right on the plate terminal here, and I'm right in the right spot. Simple as that. This is probably an AVC bias generating. I won't know. I don't. Well, maybe it is. It's a voltage drop here designed to create bias voltages. So you have a bias voltage being fed up here for that tube, and a bias voltage a little different being fed up through all this for this tube. That would explain the stable reading on the voltmeter here. It's really coming from this voltage divider down here. So all I got to do is just get right on the plate here. Now that's a high voltage spot. No, it's not. No, it's not. It's not a high voltage spot. I don't know what I'm talking about. Let's try it. I'll try and get on the plate of this with my voltmeter back in DC mode. Take this off of here. Sooner or later we'll figure out a way to do this. Leave the antenna on. Take the ground off over here. Put the ground back on the radio. Where's a good spot? Right here. Better spot is over here. Let's do it like something. Okay, there we go. Meter's set to DC. DC negative, and a bunch of volts. Okay. We want to hit the plate of this tube. This is the first audio tube. Is it identified? I don't know. First audio tube. 6K5. First audio tube. Where's that? Where's that guy? So this one's getting its feed right from the antenna. That's the output tube, rectifier tube. So maybe that. Oh, jeez. Maybe what? How can I recognize this for sure? Note it, the 6K5. Pull it out and look at it. There's the name right there. 6K7. 6K7. Guess what? That doesn't even appear. Here it is, 6K7. Okay, so we gotta find this guy and this guy. The tuning capacitor is way back here. see this connection. I can see the 6A8. I've seen the 6K7. There's only 2 more tubes possible. Where are they? Is there a tube hidden from view here that I'm not? Oh my gosh. Wait, this guy? Way down here? Nice brand new looking tube. This is one of the ones that was replaced. I think. And I think a lot of things here. Can't see what tube it is. J5. So it appears to be. Hard to read. 6J5, no doubt about it. 6J5. 6J5. So this is the detector tube. That means this is a 6K7. There's a tube missing. There's a tube missing in this radio. So the tube I'm after has to be the one in the can here. Really? Audio. Well, that could be. No, it couldn't. Well, anything's possible, but you just wouldn't imagine that they would put a can around that tube. Oh my God, this is just going crazy here. I'm losing it completely. Holy smokes. Let's just go over this again. We got the 6K7. I know where the 6A8 is. The 6J5 is in the corner. Then we use the 6K5 in the can. Why do I even care? Because I'm looking for the plate connection. Oh, look at that. They've shown a little dot on the side of the tube there. That indicates it's a cap. It's a cap on the top. That fits that tube. So that's the tube. Okay, so if that's a tube, then we're talking about way down here. And the plate on a 6K. Oh, I'm just totally forgetting what I'm doing. I'm really losing it here. What am I doing? It's a 6J5 I want to get on the plate too. Oh my God, I'm really losing it. Just losing it here. 6J5. Okay. I've stopped losing it. I have found it. Down here. Yeah, okay. 6K5 is down there. 6K5. 6J5, rather. Boy. 6J5. And they come up with better names for these tubes. 6J5. Plate is on 3. We want to get on the plate circuit of the 6J5. Plate circuit of the 6J5. Plate is 3. I think I got there. 3. Now the set is not on, so I'm just going to practice here. So, okay, there's the key. 1, 2, 3 would look like this guy right here. What we're expecting there is a negative voltage. I'm going to use the quick read and bring it out. A lot of stuff hooked up to that pin. 2 resistors and a capacitor. Interestingly enough, they connect back to the wire I was tracing earlier. No, they don't. No, they don't. Well, maybe they do. I don't know anymore. I don't know anymore. Okay. So we're expecting a negative voltage here. I'm not going to connect it up yet. Let's turn on the radio again. Wow, what a day. See, normally all this stuff would happen, and then you turn on the video and start videoing. And hey, it's all working again. Everything, always got it right. I'd look like a genius if I did that. That's what I'd look like. But I'd rather show you everything that goes on, including all the nonsense, which it's probably a little hard to watch at times, I would think. Okay, and DC here. Good show there. Okay, come on, meter. Show me. I got it on. 150 volts, negative upscale. Go upscale. Oh, goody. No hum in the radio. Okay, I think we made it for all that. Now, tune the radio, and that should go up and down. Oh my gosh, it's not changing. So we may be encountering another problem in this radio. Nothing changing at all. Well, that got it, didn't it? Yeah, volume's up very high too, as you now know, as we all know. How can I possibly do an alignment with this voltage? It's not changing. The alignment in this radio is so far off that it's running on its base bias, and the AVC voltage never catches up. That's a little hard to believe, but that could be the case. So I'm all ready to put a signal into it instead of this antenna. Let's do that, because I can put a whopper of a signal in, and we should get something coming out on the meter. Okay, so this, I'm going to ground this. Put this right on the antenna. There is a capacitor in the lead, in a little box, so I'm not going to, otherwise I might be inclined to put a capacitor there. Actually, we'll do that later to make this more antenna-like. Okay, I've got to move you over here for now. What I'm going to do is I'm going to put a signal into the antenna that is equivalent to where the radio is tuned. Tuning the radio to, we'll go for 1,000,000, because that's a nice round number. Here we are, 1,000,000. This is a very strong signal, but not crazy strong yet. We should, and volume up. Oh, what band am I on? I'm on the broadcast band. Of course I am. And I'm tuning around, expecting that. Almost dead on 1,000,000, in fact. I'll turn this down a little bit. So this meter should be swinging up and down. I'm going to turn the volume down so we're not blowing our ears off, and I'm going to jam stronger signals into the radio. So what's happening is the AVC voltage that's being developed is not larger than the base bias voltage that's sitting here, unless you put a super strong signal in. That would make alignment a little bit tricky. It could still be done. But it would be better or nicer if this, how high is this? So we're in the 5 volt scale, so we're looking at a voltage of about 2 volts sitting here. 2 volts negative. So the argument would be the 2 volts negative is coming from this guy. 2 volts doesn't sound like much to me. So what that would argue then is if the AVC can't overcome 2 volts, it's because the AVC signal itself is weak for some reason. The AVC voltage. We notice the audio is weak. AVC voltage is weak. Audio is kind of related to this. AVC just here. Now, I don't think I've tested the tubes in this radio. I believe I have not. So perhaps this is weak. The radio's also been altered to some degree. I don't know to what degree, but it's been altered to incorporate newer versions of some of these tubes. I think that's what's happened. And maybe something happened during that process. But it will generate. Here's the thing. Let's say I put this in a normal, the volume control into a normal. Here's the thing, okay? The thing. Get your notebook out. I'm going to tell you the thing. So that would be, probably under proper circumstances, that would be a reasonable listening level. So at this level, the signal doing that would probably not generate much AVC. If we start fooling with it here. Now, is that weird? I don't think that's weird, because the volume's turned down. So I'm turning up and down on the input frequency strength. So it's not too far off. I mean, the objective here is to control the output volume and maintain it at a fairly level state, even though the signal strength may be varying as you. It's really meant for tuning between stations. You have weak stations and strong stations, and without AVC, you got to have your hand on the volume control. You become the automatic volume control as you tune along. You get hit with these strong stations, you got to turn it down, and the weak stations, you got to turn it back up. And they figured out, the engineers figured out a way to automate that, make that automatic, so you don't have to hold the volume control anymore. And as you tune along, the radio's sensitivity is going up and down based on the signal coming in. The more signal comes in, the radio's sensitivity automatically comes back, and that restores the volume to some kind of steady level, or range somewhere in here that you. It doesn't matter what signal you tune in. What will change is the background noise. And this is why when you tune between stations with an AM radio, you hear a great big hiss. It's not because the hiss is there. The hiss is not there. In fact, normally you should be tuning into a quiet spot. But there's a hiss and a roar coming out because the automatic volume control has cranked the radio right up, so to speak, to compensate for the very low signal. And that's why you hear so much noise. So, in fact, when I'm using my shortwave radios where I can, I turn off the automatic volume control, the AVC, and I operate a RF level control manually. And I find that much, much nicer, because as you tune off of signals, instead of getting a big rush and roar, you get silence. You get just a little tiny hiss. It's much better. So AVC, a great thing, destroys the radio listening experience and converts it. This is all you ever heard all your life, especially if you're my age, tuning AM radios, that's what happens, right? You tune between stations, crackling and hissing going on. Gives you a mistaken impression of things. Oh, another speech. I'm doing speeches because I can't make this work well. Okay, let's at least get one thing done. We will now check the IF. We will attempt to pump the IF frequency into the radio. And what is the IF frequency? What's the frequency, Kenneth? And so we're going to find it written on here somewhere, maybe. Sometimes written right around here. No, they're keeping it secret on this document. Sometimes they make a note. Note number 29. The audio shorting switch is located on the selector arm of the Model 38C7. What? Okay, there's a nice diagram showing all the voltages that should be on the tubes. I have not made use of that. Might even get, there's a tube layout diagram here. I don't have to be so stupid about these things anymore. Oh my gosh. Yeah. So the risk with my style of video making, which is show it all, dirty laundry and all, is yes, you show dirty laundry, and then people's opinions of you go downhill. Hey, look at the guy. He hasn't got a clue. He hasn't got a clue. He's clueless. Oh, they're even giving a dial calibration. I didn't notice that either. Oh man, what else is in here that's secret? Move pointer 1/16 of an inch to the left of the dot. One-16th of an inch to the left of the dot. That means they built this whole radio, designed the whole thing, put a dot on there, and went, and in the end went, oh, it's in the dot's in the wrong spot. We got the dot in the wrong spot. Well, just tell them to do it 1/16 of an inch over. Oh boy. What did I say I was going to do? I was going to, find the IF frequency. Find the IF frequency. It's intermediate frequency chart, 470. Okay, we got it. 470. 470. Don't look any further. 470. So we're dumping this right into the antenna in the hopes it'll work its way through the radio and get to the IF circuits. That's our secret hope here. Can we get anything done? Volume up, please. Oh, there it is. That's good. Actually, well, you want to watch this. You want to watch this frequency number right here. So we should hear the maximum volume when this says 470. Actually, 469 would be better. Okay, here we go. Seems pretty good. Let me just give it a little more oomph. Looks pretty good. And that AVC meter did not move the whole time. The whole time I did that. So we're going to do this. We're going to turn down the volume, turn up the output, run this again. Oh, just a little tiny bip right there. The problem with doing this with an AVC voltage is the AVC is automatically, not automatically, but the voltage takes time sometimes to relax, and there's a capacitor in there. It's integrating the voltage. Takes time, integration over time. So you got to go a little slow there. Okay, good. So look at the number. The number is 468. It's good. There's no reason to think there's any tuning benefit to adjusting the IF. Okay. Oh man, I don't know. I don't know if you enjoy this kind of thing or this is driving you nuts to watch. I don't know what the story is with that. All I know is I did all this stuff to conclude that everything's okay at the end. Holy smokes, what a day. What a crazy day. Tomorrow's gonna, unless I can get this meter going, we'll have to do tomorrow's stuff by ear also. Yikes. It's not the best way to do it. Okay, thanks for watching. Sorry about the whole thing. We'll see you on the next video. Hey, thanks for the super likes. Or super thanks. Thanks for the super thanks. And thanks for the likes. See ya.